October 12th, 2025. 8 days have passed since we received the latest official update concerning the celestial interloper, 3EI Atlas. This entity has been gracefully navigating the expanse beyond our sun, leaving behind mere hints of exotic extraterrestrial chemistry. We've been presented with no definitive imagery, no straightforward clarifications, only a narrative meticulously crafted and presented as a peculiar comet. But is that the genuine account? The fissures in this presented story are progressively widening. Consequently, this evening, we will deconstruct this official account and pose the singular question that occupies everyone's thoughts but remains unspoken. Is the established narrative the unvarnished truth? Or is there a more intricate reality unfolding behind the scenes? And as we continue with our innovative multi-part presentation, the revelations only grow more disquieting. We will investigate a rogue black hole silently drifting through our Milky Way galaxy, an unseen predator with the potential to fundamentally alter our understanding of cosmic security. We will then turn our attention to the immense solar disruption currently occurring on the Sun, a phenomenon that could have repercussions far beyond atmospheric disturbances. Following this, we face the ultimate countdown. Scientists cautioning that the very fabric of the universe might be destined for a catastrophic collapse, a big crunch, and the timeline for this event is significantly shorter than anticipated. To compound these concerns, a steady, albeit quiet, stream of satellites is plummeting back to Earth on a daily basis, averaging between 1 and 2 per day. The pertinent question is, why is this not a more prominent topic of discussion? If these enigmas have captured your attention as thoroughly as they have mine, please remember to click the like button and subscribe to ensure you don't miss any crucial developments as this unfolding story progresses in real time. We encourage you to share your location and the current time in your region in the comments, along with your thoughts on whether you believe we are being privy to the complete truth regarding these momentous discoveries. Furthermore, if you wish to contribute to the growth of this community, please share this video across platforms like X, Facebook, Reddit, or even within your personal group chats. Your engagement is the driving force that enables us to continue pursuing and presenting stories of this nature. For that, we extend our sincere gratitude for your unwavering support. Part 1. The arrival shrouded in uncertainty. On July 1st, 2025, an entity made its appearance, originating not from our sun, but from the deepest recesses of interstellar space, and it immediately provoked considerable scrutiny. It's probable you haven't encountered this information, as most individuals remain unaware. However, within the hushed environs of astronomical observatories and research facilities scattered across continents, scientists began a clandestine exchange of encrypted communications, arranged urgent virtual conferences, and grappled with data that defied conventional expectations. They designated it 3 Atlas, with the catalog identifier C-25 and 1. The Atlas Survey Telescope, situated in Chile, was the first to detect it. A faint speck traversing the celestial backdrop, its trajectory suggesting an impossible origin. This marked the third confirmed instance of an interstellar object detected by humanity, following the renowned Oumuamua in 2017 and Comet Borisov in 2019. Do you recall Oumuamua? That enigmatic, cigar-shaped anomaly that accelerated in a manner inexplicable by gravity alone, which failed to exhibit the typical outgassing expected of a comet, and which vanished back into the cosmic expanse before we could obtain a thorough examination. Atlas presented a different profile, or perhaps it was remarkably similar. Consensus remained elusive. The orbital mechanics presented a clear picture. The object was on a hyperbolic path, signifying it was not gravitationally tethered to our solar system. It hailed from an unknown, unimaginably distant location and was destined to depart, rejoining the void between stars. Its inbound velocity was recorded at approximately 60 kilometers per second, which translates to about 130,000 miles per hour for those who prefer cosmic speeds expressed in more familiar terrestrial units. This is an extraordinary speed, exceeding any velocity achieved by human endeavors and surpassing the solar wind. It is so rapid that when calculations are reversed, tracing its trajectory into the past, one finds oneself pointing towards a region of space from which no known star should have dispatched it. The object was projected to reach its perihelion, its closest orbital point to the Sun, on October 30th, 2025, passing at a distance of approximately 1.4 astronomical units from our star. For context, 1 astronomical unit represents the average distance between the Earth and the Sun. Therefore, Atlas would traverse the inner solar system, crossing Mars' orbital path but remaining well outside of Earth's trajectory. Its closest approach to Earth would be approximately 1.8 astronomical units, a distance substantial enough to allay fears of any collision risk, even among the most apprehensive observers. This was not a scenario of impending doom, nor a cautionary tale like, "Don't look up." Any perceived danger, if indeed there was any, was not of a kinetic nature. However, anomalies began to accumulate, much like evidence collected at a crime scene. Initially, estimates of its size varied. Preliminary calculations suggested Atlas could span tens of kilometers, making it significantly larger than its 2 interstellar predecessors. Conversely, other assessments diverged dramatically, indicating a much smaller object possessing peculiar reflective characteristics. This degree of uncertainty was in itself unusual. Contemporary astronomy has achieved considerable proficiency in determining the dimensions of celestial bodies. When estimates differ by factors of 10 or more, it implies that something about the object's surface or configuration is confounding our instruments in ways that should not occur with a conventional comet. Subsequently, the chemical analyses were received, and they were entirely perplexing. Most comets, upon approaching the Sun and experiencing increased temperatures, begin to release gases from their nuclei, forming magnificent tails that can extend for millions of kilometers across the solar system. Atlas deviated from this established behavior. Spectroscopic examination revealed a dominant presence of carbon dioxide in its emissions, with minimal amounts of water. Even more remarkably, certain observations detected elevated concentrations of nickel in these emissions, an element that should not be present in such quantities in the exhalations of a natural comet. One might assume that astronomers would be vociferously announcing these findings. One might envision emergency press conferences, expedited research papers, and telescopes worldwide reorienting to track this extraordinary visitor. While some of this did occur, a significant portion of the response was subdued, marked by caution, qualifications, and hesitant language. Many astronomers publicly characterized Atlas as merely an unusual yet natural comet, an outlier in its class, but not fundamentally beyond explanation. They emphasized the diversity of comets, noting that each star system possesses its own unique chemistry, and that not every visitor is expected to conform to the composition of objects originating in our immediate cosmic vicinity. Nevertheless, whispers began to circulate within the comment sections of preliminary research papers, in hushed discussions at scientific conferences, and in encrypted chat channels where researchers felt more at liberty to express themselves than in peer-reviewed publications. Some posed a question that hovers at the periphery of respectability in modern astronomy. What if Atlas was not entirely a natural phenomenon? What if we were observing something manufactured, something technological, something intentionally dispatched? The term probe began to appear, typically embedded within conditional clauses and hypothetical scenarios. The word alien was uttered even more discreetly, often accompanied by a nervous chuckle, a social cue indicating the speaker recognized they were venturing into precarious territory. Careers have been jeopardized by taking such suggestions too seriously, and reputations have been built upon dismissing them. However, the data itself remained indifferent to careers and reputation. The chemistry did not defer to professional standing. As October drew nearer and Atlas approached, with our telescopes gathering increased illumination from its surface, the anomalies did not resolve into easily digestible explanations. On the contrary, they seemed to multiply. And so, we find ourselves here. An entity from another star system is presently traversing our cosmic neighborhood. As you absorb these words, it is exhibiting characteristics that do not align with any established models for natural celestial bodies. The data we are receiving is fragmented, dispersed, and at times, contradictory. The very institutions we rely upon to interpret such phenomena are employing carefully measured language, which could signify scientific prudence, or it could indicate something entirely different. The central question is not whether Atlas is peculiar. Its peculiarity is universally acknowledged. The question pertains to the nature of this peculiarity and the authority that will determine its classification. In the subsequent segment, we will delve into the observed pulsations and rotational patterns and address the query that keeps a particular subset of scientists awake at night. Is it a deliberate signal or simply a random tumble through the void? Part 2. Pulses in the darkness, signal or spin. Light carries narratives if one possesses the ability to decipher it. Every photon that reaches our telescopes conveys information encoded within its wavelength, its polarization, and its temporal arrival. When astronomers study an object like Atlas, they are not merely observing a point of light in the sky. They are analyzing the fluctuations in its brightness over time, constructing what is termed a light curve, a graphical representation mapping illumination against hours, days, and weeks. Most comets produce irregular, chaotic light curves. They exhibit erratic tumbling through space, their rotation destabilized by the uneven forces of outgassing, and their surfaces are often pockmarked and asymmetrical. The variations in brightness we observe are essentially akin to noise, random fluctuations as different surface features capture and reflect the sun's light at varying angles. It is the optical equivalent of static, predictable only in its inherent unpredictability. Atlas did not conform to this typical pattern. Or rather, it did and it did not, which may be even more unsettling. Its light curve displayed variations that were unusually regular. Changes in brightness occurred at predictable intervals, suggesting a structured geometry rather than chaotic tumbling. Certain segments of the data exhibited periodicities that prompted astronomers to lean closer to their monitors, meticulously rechecking their calibrations and questioning whether they were interpreting the data accurately. The technical designation for this phenomenon is photometric periodicity, and it is precisely what one would anticipate from a spacecraft intentionally rotating to maintain orientation, or from a probe designed to transmit patterned flashes into the cosmos, or indeed from any engineered system requiring precise control of angular momentum. To be fair, it is also a characteristic that could be observed from a natural object possessing an unusual, though still explicable shape, perhaps a contact binary, two lobes connected by a narrow neck, rotating in a stable configuration. However, when the polarization data arrived, the situation became even more peculiar. Polarization quantifies the orientation of light waves as they propagate through space. Unpolarized light vibrates in all directions perpendicular to its direction of travel. Polarized light vibrates in specific planes, and the degree and orientation of this polarization provide insights into the surface characteristics of whatever object reflected or scattered that light. Rough surfaces tend to depolarize light, while smooth surfaces can generate strong polarization signatures. Certain geometric arrangements result in what is termed negative polarization, where the polarization flips in an orientation opposite to what would normally be expected. Atlas exhibited extreme negative polarization at specific angles, reaching values that pushed the limits of what models predicted for any known natural surface composition. One research paper described it as anomalous polarization behavior, inconsistent with standard models of cometary dust. Another paper utilized the phrase geometric albedo features, suggesting a non-random surface structure. These are the types of meticulously qualified statements scientists employ when they encounter phenomena that defy conventional understanding, but for which they are not yet prepared to offer a definitive interpretation. Imagine a lighthouse. Its beam sweeps across the ocean at regular intervals, a precisely timed pulse conveying information to any observer with the capacity to see. Now, envision that lighthouse tumbling through space at 60 kilometers per second, and instead of a focused beam, it is reflecting sunlight in patterns that repeat with a regularity too consistent to be coincidental, yet not so regular as to be unequivocally artificial. This, in essence, is the predicament we are facing. It might be a beacon, or it might be the universe's most inconveniently shaped rock. The data pertaining to non-gravitational acceleration introduced another layer of complexity to the puzzle. When an object's orbit is tracked with sufficient precision, minute deviations from the path dictated solely by gravity can be detected. Comets routinely exhibit these deviations. Outgassing acts as a subtle thruster, nudging the comet slightly off course in directions determined by the vents from which the gas is expelled. For a typical comet, these forces are, on average, symmetrical and tend to equilibrate over time. In the case of Atlas, the non-gravitational acceleration displayed patterns that were difficult to reconcile with conventional outgassing models. Some researchers proposed that the object was a dust-rich comet, essentially a rocky body shedding primarily solid particles rather than gas, generating forces through the impact of solar radiation pressure on these particles rather than through volatile venting. This hypothesis offered an explanation for some of the chemical anomalies and certain acceleration irregularities. It was a plausible theory, a reasonable compromise between describing it as a peculiar comet and a potential alien probe. It did not account for every observation, but it explained enough to be considered credible. And perhaps that is precisely what it was. Perhaps Atlas was simply occupying a poorly explored region within the parameter space of possible cometary bodies, demonstrating that our models required refinement rather than wholesale revision. The universe is under no obligation to conform to our expectations. It remains indifferent to our desire for straightforward explanations and coherent categories. However, the persistent question that troubled researchers poring over those light curves late into the night was this: if one were tasked with designing a probe intended for interstellar travel, a probe that could be detected yet not overtly technological, a probe that could skillfully navigate the fine line between being conspicuous and appearing as merely a natural celestial body, what characteristics would be incorporated? The likely design would involve something that largely mimicked natural phenomena, something that could plausibly be mistaken for a comet or asteroid. Yet, it would possess just enough geometric regularity to capture the attention of those who scrutinized it closely. The objective would be ambiguity, deniability. It would be designed to foster debate among observers regarding their findings. And this is precisely what we have encountered. Radio astronomers detected nothing. Naturally, there were no clear periodic signals, no modulated carrier waves, no beacon transmitting across the electromagnetic spectrum in a manner that would unequivocally signal artificial origin. However, the absence of evidence is not definitive proof of absence. This is particularly true when our listening encompasses only a narrow range of frequencies, when our radio telescopes have limited windows of observation, and when the object is moving at such a high velocity that any signal would undergo significant Doppler shifting, potentially rendering it unrecognizable. Thus, we are left with ambiguity, patterns that could be deliberate signals or merely the result of its rotation. Its chemistry might be extraterrestrial, or it might simply originate from a stellar nursery vastly different from our own. Its acceleration could be attributable to outgassing, or it could stem from an unknown source. Every data point presents multiple interpretations, sometimes three, and selecting among them necessitates either more information than we currently possess, or a leap of faith in a particular direction. How does this compare to other interstellar visitors we have detected? What insights can be gleaned from historical records concerning objects that exhibit unusual behavior? This is where we will turn our attention next, to the shadow cast by Oumuamua and the lessons learned about clear observation. Part 3. The Shadow of Oumuamua, October 19, 2017. The Pan-STARRS telescope in Hawaii flagged an object traversing the inner solar system on an improbable trajectory. Initially, astronomers presumed it to be an asteroid or comet originating from our own Kuiper belt, its inward path influenced by some gravitational interaction. However, within days, as more observational data was compiled, the orbital calculations converged on a perplexing conclusion. This object, subsequently named Oumuamua, Hawaiian for scout or messenger, had originated from interstellar space. This marked the first time in human history that we had definitively confirmed an object passing through our solar system that originated from beyond it. The first irrefutable evidence of a visitor from another star, and it was profoundly peculiar. Oumuamua accelerated as it departed the solar system, a small yet measurable push that could not be attributed to gravitational forces alone. It exhibited no cometary tail, no discernible outgassing, and no visible signs of the volatile ices that should sublimate when warmed by the sun. Its inferred shape, based on fluctuations in its brightness as it tumbled, suggested an extreme elongation, perhaps 10 times longer than it was wide, a geometry virtually unknown among natural asteroids or comets. Some estimates extended this elongation even further, depicting a needle-like or cigar-shaped object that defied conventional formation mechanisms. The scientific community responded with a deluge of papers proposing naturalistic explanations. Perhaps it was a fragment of a planet dislodged by tidal forces. Perhaps it was composed of unusual materials that did not visibly outgas. Perhaps the acceleration was caused by the sublimation of hydrogen ice, too faint to detect but sufficient to provide propulsion. Perhaps. Each proposed solution addressed one issue while simultaneously creating new ones. Each hypothesis required special pleading, invoking conditions that were possible but uncommon, convenient but unsubstantiated. And then Abraham Loeb stepped forward. Loeb, the chair of Harvard's astronomy department, a scientist with an impressive publication record and considerable institutional credibility, publicly suggested that Oumuamua might be artificial. He posited that it could be a solar sail, a thin, reflective sheet propelled by radiation pressure, either a piece of derelict alien technology drifting through space, or more provocatively, an active probe from another civilization. The scientific establishment reacted with what can only be described as outrage. Loeb was accused of sensationalism, of damaging the reputation of astronomy, and of abandoning scientific rigor in pursuit of publicity. The backlash was so intense, so visceral, that it raised its own questions about the underlying reasons for such defensive reactions to the notion of extraterrestrial technology. 2 years later, in August of 2019, another interstellar visitor arrived. Designated Borisov, this object behaved as a conventional comet. It outgassed normally, displayed a visible tail, and exhibited chemical compositions consistent with comets originating from our own solar system. The astronomical community collectively exhaled in relief. See, their implicit message seemed to convey, interstellar objects are just like ours. Oumuamua was an anomaly, but ultimately explicable. Everything is back to normal. Except that Atlas is preventing a return to normalcy. In certain respects, Atlas bears a closer resemblance to Oumuamua than to Borisov. Both objects exhibit non-standard acceleration that challenges simplistic gravitational models. Both display chemical or physical properties that do not fit neatly into our established taxonomic classifications. Both occupy a liminal space between comet and asteroid, neither entirely one nor the other. However, Atlas may be substantially larger than Oumuamua, assuming the size estimates are accurate. It exhibits the peculiar carbon dioxide dominant outgassing that neither of its predecessors displayed, and the nickel signatures, the extreme polarization, and the regular fluctuations in brightness all propel it into uncharted territory where our comfortable analogies begin to break down. Where Atlas most significantly diverges from its celestial kin is in the reaction it has elicited. With Oumuamua, we were surprised, uncertain about how to interpret our observations, and open to entertaining a range of possibilities. With Borisov, we felt relieved, eager to categorize it within familiar frameworks. With Atlas, there's a palpable sense that the scientific community has, in essence, predetermined its beliefs before all the evidence has been fully assessed. Following the controversy surrounding Oumuamua, the accusations and counter-accusations, and witnessing a respected colleague being subjected to intense scrutiny for posing uncomfortable questions, many astronomers appear to have collectively and subconsciously resolved to proceed with extreme caution, to prioritize naturalistic explanations, and to minimize the significance of anomalies. This phenomenon is often referred to as overcorrection. When an individual experiences a burn from touching a hot surface, they may subsequently develop an excessive wariness around all stovetops, even those that are clearly switched off. When scientific bodies have experienced public backlash due to speculation about extraterrestrial engineering, they may become excessively reluctant to consider any evidence that points in that direction, even when such evidence warrants serious scrutiny. The lingering emotional impact of the Oumuamua discussion might be influencing current interpretations of Atlas, fostering a predisposition towards conventional explanations. This predisposition is as unscientific as assuming that anything unusual must be manufactured. Lowe himself has been meticulously documenting these anomalies, contending that our existing analytical frameworks are inherently predisposed to overlooking signatures of technology. He highlights that we have a solitary verified instance of a civilization constructing objects capable of interstellar travel, our own, and that we have been dispatching probes beyond our solar system for numerous decades. The concept that another civilization might undertake a similar endeavor is not outlandish conjecture. It is an application of the mediocrity principle, the notion that we are not unique, and that what transpired here has likely occurred elsewhere as well. If we find the justifications for natural explanations inadequate, if we resort to increasingly improbable conditions to uphold conventional interpretations, perhaps we are overlooking the most straightforward explanation, one that is merely psychologically challenging due to its implications. Historical context is pertinent here. Throughout the annals of astronomy, we have encountered celestial bodies that appeared peculiar, defied immediate explanation, and fueled speculation about non-natural origins. Pulsars, upon their initial discovery, were humorously dubbed LGMs, or little green men, owing to the seemingly artificial precision of their regular radio pulses. Quasars challenged our understanding of the maximum energy output achievable from a given volume of space. Fast radio bursts continue to lack a fully satisfactory explanation. In each of these instances, we eventually identified natural mechanisms capable of producing the observed phenomena, mechanisms that were often more extraordinary and intriguing than any artificial explanation. However, here's the crucial point. Just because we have uncovered natural explanations for past anomalies does not guarantee that every anomaly will have a natural explanation. This is the fallacy of induction, the assumption that because something has been true in the past, it must necessarily hold true in the future. At some juncture, if we ever encounter unequivocal evidence of extraterrestrial technology, it will invariably appear anomalous. It will confound our initial theoretical models and provoke precisely this kind of debate. And if we have conditioned ourselves to perpetually dismiss the technological hypothesis, to invariably identify a natural mechanism, however contrived, we risk missing the most significant discovery in human history, simply because we prefer being safely incorrect over uncomfortably right. So, where does this leave Atlas? Adrift in space, occupying the nebulous territory between certainty and conjecture, observed by instruments that capture mere fragments of truth, never the complete picture. This brings us to what may be the most disquieting element of this narrative: the absent data, the images that ought to exist but have not been disclosed, the lacunae in the public record that could be innocuous or could signify something more. Let us investigate what remains unseen and why its absence might hold greater consequence than what is visible. Part 4. The Missing Data Quandary. Modern astronomy is an endeavor rich in data. We possess orbital telescopes, instruments on Mars, and observatories distributed across every continent. When an object of interest enters the inner solar system, numerous instruments can be directed towards it, capturing imagery across multiple wavelengths, thereby constructing a comprehensive depiction of the phenomenon. That, at least, is the theoretical framework. The practical application, particularly concerning Atlas, appears considerably different. The European Space Agency disseminated a gift from the CASS camera aboard the ExoMars Trace Gas Orbiter. CASSIS, engineered to image the Martian surface with high resolution, was repurposed to capture Atlas during its relatively close passage by Mars. What did this yield? A faint pinpoint traversing the starfield, a nebulous smudge barely distinguishable from background noise, an image confirming Atlas's existence and its position as predicted by orbital calculations, but revealing virtually nothing about its physical characteristics. For an object purportedly spanning tens of kilometers, passing within the observational range of a high-resolution camera, the lack of discernible detail was profoundly disappointing. Either Atlas was substantially smaller than some estimates indicated, or it possessed an unusually low reflectivity, or the camera was not optimally positioned, or a confluence of factors conspired to produce the least informative image imaginable. Subsequently, there was the Perseverance rover, NASA's premier Mars mission, outfitted with navigation cameras that routinely scan the Martian sky for dust devils and clouds. This rover caught sight of Atlas on October 4th as it traversed the Martian sky. What did that image reveal? A luminous streak, a line of light consistent with an object moving against the backdrop of stars. Its duration and trajectory aligned with Atlas's predicted path. Once again, confirmation without revelation. We ascertained that Atlas was precisely where it was expected to be, moving as anticipated, but nothing regarding its actual composition. These images were disseminated, publicized, and detailed in press releases and news reports. They conveyed almost no new information. And perhaps that is acceptable. Perhaps these instruments were simply not designed or positioned to yield superior data. However, this is where the narrative takes a curious turn. Other instruments should have captured images, superior images, and these have not come to light. The Mars Reconnaissance Orbiter carries high-resolution imaging science experiment, HiRISE, capable of resolving features on the Martian surface as small as 1 meter across. When an interstellar object passes relatively nearby, one would anticipate HiRISE being tasked with acquiring imagery, multiple images, tracking the object across several orbits to compile a comprehensive data set. Where are those images? The MAVEN spacecraft, engaged in studying Mars's upper atmosphere, possesses optical instruments that could have provided supplementary observations. Where is that data? The Mars Odyssey orbiter, operational since 2001, is equipped with thermal imaging capabilities that might have detected heat signatures or assessed the object's surface temperature. Has that data been released? The official explanations, when offered at all, cite sensitivity limitations, scheduling conflicts, and instrument constraints. HiRISE was designed for planetary surfaces, not rapidly moving celestial objects. MAVEN's instruments are optimized for atmospheric science, not asteroid tracking. The data processing pipeline requires time, calibration, and verification before public release. Furthermore, there was the government shutdown in early 2025, which disrupted numerous NASA operations and generated a backlog of data processing tasks that are still being addressed. These explanations are plausible. They are reasonable. They may even be entirely accurate, but they exist within a context where the absence of data creates fertile ground for alternative narratives. When individuals anticipate seeing something and do not, when institutions with a history of meticulous documentation suddenly exhibit gaps in their records, suspicion readily fills the void. There is a long-standing history of assertions that space agencies have altered, delayed, or withheld anomalous imagery. The face on Mars, which was ultimately revealed to be a mountain sculpted by erosion and shadow, but was initially presented without adequate clarification, instilled a generation with distrust regarding NASA's image releases. Numerous conspiracy theories contend that photographs from lunar missions, Mars rovers, and orbital surveys have been doctored or retouched to eliminate evidence of structures, artifacts, or other anomalies. The majority of these claims are baseless, representing pattern recognition in noise and the perception of design in randomness. However, the prevalence of largely unfounded assertions does not invalidate every claim, nor does it preclude agencies from being less than forthcoming with challenging data. The European Space Agency implements a 6-month embargo on a substantial portion of its raw data. Images and measurements are gathered, processed internally, utilized by scientific teams, and only subsequently released into public archives. This is standard procedure, intended to provide researchers with adequate time to analyze data before broader scrutiny. It is scientifically justifiable and practically essential. It also implies that detailed images of Atlas might currently reside on ESA servers, images that will not be publicly accessible until mid-2026. These are images that could potentially answer questions we are currently debating in informational darkness. This situation gives rise to what might be termed the data vacuum effect, when the public is aware that observations should exist but cannot access them, when the disparity between what was observed and what has been released becomes sufficiently significant to be noticeable. Narratives rapidly emerge to fill the void. Some of these narratives are steeped in paranoia. Some are conspiratorial. Some propose cover-ups, hidden knowledge, and institutional deception. And some, perhaps, might even be accurate, or at least partially so, because the absence of evidence truly does constitute evidence of absence when that evidence was reasonably expected to be present. Consider the underlying incentive structures. If Atlas is merely an unusual comet, releasing all available data immediately carries minimal risk and aids in advancing scientific understanding. If Atlas is something more ambiguous, something that might be artificial or exhibits characteristics we cannot explain, releasing that data introduces complications. It invites intense scrutiny. It raises questions that the agency may not be prepared to address. It risks revealing capabilities or limitations of our instruments that some might prefer to keep confidential. It poses a danger of public apprehension or confusion if the implications are conveyed without appropriate context. None of this definitively proves any concealment, but it establishes that plausible motivations for selective disclosure exist, and that the gap between what has been observed and what has been shared exceeds what routine scientific caution would normally dictate. You are being asked to trust that the institutions examining Atlas are providing the complete narrative, while simultaneously being informed that a considerable portion of that narrative will not be available for review for months or even years. This is a significant demand, particularly given the stakes involved, which leads us to the fundamental question underlying this entire investigation. Why does it matter? If Atlas is a natural phenomenon, we gain an interesting insight into interstellar chemistry and move on. If it is artificial, well, that constitutes the most monumental news in human history. But beyond these potential outcomes, what is truly at stake in how we interpret anomalous objects? What are we truly contending with when we debate whether Atlas is a comet or something else entirely? Let us examine the very nature of belief and its associated costs. Part 5. Belief, skepticism, and the stakes. Ask yourself a straightforward question. Why is it significant whether Atlas is merely a comet or something more? What changes in your life, your plans, your perception of your place in the cosmos? If the answer leans in one direction or the other, if Atlas is natural, if all those anomalies resolve into explicable chemistry and physics, we gain a rare window into the composition of another star system. We learn that planetary systems located light years away can produce comets with chemical signatures distinct from our own, that the conditions governing stellar formation exhibit greater variability than we previously assumed, that the universe possesses a diversity that we are only beginning to catalog. This is scientifically valuable, intellectually stimulating, another data point in our expanding comprehension of cosmic chemistry. We publish research papers. We refine our theoretical models. We then proceed to the next enigma. If Atlas is engineered, If we are indeed observing evidence of extraterrestrial technology, then everything changes. This is not an exaggeration. The confirmation that intelligence exists beyond our world, that civilizations can emerge and endure long enough to dispatch probes between stars, that we are not alone in the universe. That realization would represent the pivotal juncture around which human history revolves, marking a distinct before and after. Our understanding of our significance, our future, our obligations to the cosmos, all of it would be irrevocably transformed overnight. However, these are the straightforward outcomes, the binary possibilities. The more complex question lies in what transpires in the interim, within the ambiguous territory where we currently reside. Because presently, today, we remain uncertain about Atlas's true nature. We possess data that points in multiple directions. We have institutions making claims that we cannot independently verify. We have information gaps that could be benign or could be cause for suspicion. And we, the public, are being asked to form our beliefs without access to the complete evidence. This is where psychological factors enter the narrative. Humanity's response to potential first contact, or even to ambiguous indicators thereof, reveals our species' character. Do we approach the unknown with curiosity or with apprehension? Do we demand transparency from our governing bodies, or do we yield to their authority? Do we allow ourselves to contemplate unsettling possibilities, or do we retreat into comfortable certainties? The Atlas event, irrespective of its ultimate explanation, serves as a test of our civilizational maturity. There are institutional considerations at play as well. Space agencies rely on public funding and political goodwill. Their budgetary allocations depend on maintaining credibility, on being perceived as serious and scientific rather than speculative and sensational. Should NASA or ESA announce the discovery of evidence of alien technology and subsequently be proven incorrect, the reputational damage would be substantial. Funding could be reduced. Leadership might be replaced. Future missions could be jeopardized. The prevailing incentive structure favors caution, a demand for certainty, and the practice of making pronouncements only when they can be definitively substantiated. This is understandable. It is human. It also represents a bias that could lead to the overlooking or dismissal of genuine anomalies, as acknowledging them carries professional risks. Then there is the peril of confirmation bias, the inclination to interpret new evidence as reinforcing pre-existing beliefs. If your desire is for Atlas to be an alien probe, you will emphasize the anomalies and downplay the conventional explanations. Every anomalous data point becomes validation for your hypothesis. Every gap in the public record transforms into proof of a cover-up. You are not being dishonest or deliberately irrational. You are simply human, filtering reality through the prism of your established beliefs and aspirations. However, there exists an equally potent, opposing risk: dismissal bias, the tendency to reject unsettling possibilities regardless of the accompanying evidence. If you are firmly convinced that Atlas must be a natural object, you will highlight the conventional explanations and minimize the significance of the anomalies. Every peculiar data point becomes a minor puzzle rather than a profound mystery. Every gap in the record becomes an innocent delay rather than suspicious withholding. You are not acting dishonestly. You are merely protecting yourself from the discomfort of a paradigm shift, from the disorienting sensation of having your fundamental assumptions about the universe challenged. Both biases represent pitfalls. Both lead away from the truth. The critical question is whether one can simultaneously entertain multiple possibilities, weighing them according to the evidence rather than personal preference, and updating one's beliefs as new data emerges, rather than rigidly adhering to initial positions irrespective of what the universe reveals. This connects to a deeper philosophical inquiry. Is belief in extraterrestrial probes a modern myth, a technological age substitute for deities and celestial beings, a projection of our hopes and fears onto the cosmos? Or is it a rational deduction derived from the available data? An application of Bayesian reasoning suggesting that, given the age and vastness of the universe, the multitude of potentially habitable planets, and our own existence as proof that intelligence can arise, the probabilities favor the existence of other civilizations, possibly sending emissaries into the void. The answer is not immediately apparent. Both perspectives possess validity. Both can marshal evidence and logical arguments in their defense. What is clear is that this question holds profound significance, not only for how we interpret Atlas, but for how we understand ourselves. Are we alone? If not, what are the implications of contact? If we are being visited, observed, or simply passed by travelers from elsewhere, what responsibilities does this impose upon us? These are not abstract philosophical exercises. They are live issues with tangible consequences for how we allocate resources, how we plan for the future, and how we conceptualize humanity's role in the cosmic narrative. And here lies the uncomfortable truth. We are making these decisions, forming these beliefs, and navigating these questions with incomplete information. The comprehensive data set exists somewhere. Images that could resolve ambiguities, spectroscopic data that could corroborate or refute hypotheses, observational records that would enable us to perceive Atlas clearly rather than through the haze of selective disclosure and institutional caution. Yet, we lack access to that data. We are being urged to trust, to defer, to accept that those possessing greater knowledge are making the correct choices regarding what to share and what to withhold. Perhaps they are. Perhaps the agencies studying Atlas have sound justifications for their communication strategies. Perhaps all their actions are scientifically sound and ethically justifiable. However, the very structure of the situation, the imbalance of information, the gulf between what is known and what is disseminated, this structure itself creates the conditions for distrust and speculation. When you treat the public as children incapable of processing difficult truths, you should not be surprised when they begin to suspect you are concealing something important. Thus, we are left with uncertainty. A visitor from another star system exhibiting characteristics that challenge our established models, observed by instruments whose data is not fully accessible, interpreted by institutions with complex motivations. Atlas remains suspended in the sky, both literally and metaphorically, a question mark inscribed in rock, metal, or some entirely different substance, and we are expected to determine our beliefs about it without the necessary information for rational decision-making. Yet, Atlas is not the sole enigma unfolding in space at this juncture. Recent discoveries, fresh cosmic news, may offer context, contrast, or clues regarding how to interpret our interstellar visitor. In the subsequent segment, we will shift our focus to groundbreaking space news, to anomalies and occurrences that may be related, coincidental, or something else entirely. Because sometimes, comprehending one mystery necessitates examining all the surrounding enigmas. Occasionally, the pattern only becomes discernible when one steps back far enough to encompass the entirety of the sky. Part 6. A black hole without a home. Envision the most massive object imaginable. A neutron star? Too insubstantial. The galactic core? Too static. Now, imagine something possessing the mass of several suns compressed into a volume smaller than a city, warping space-time so profoundly that nothing, not even light, can escape its gravitational pull once the event horizon is breached. You are picturing a black hole. Now, set it adrift. Sever its connection to any galaxy, any star system, any gravitational anchor. Send it wandering through the void between the stars, a cosmic predator hunting through the darkness. In 2025, astronomers confirmed observations of what they are terming a rogue black hole. A stellar mass black hole, not gravitationally bound to any discernible system, drifting through our galaxy like a phantom vessel sailing between harbors. This is not entirely unexpected in theory. Black holes form when massive stars collapse, and the galactic dynamics governing stellar motion should, on occasion, eject a black hole from its birth cluster, initiating its solitary journey through space. What is surprising is its detection. Black holes are notoriously invisible, revealing their presence only through their gravitational influence on nearby matter or via the radiation emitted by material spiraling into them. A solitary, wandering black hole, devoid of any stellar companion, accretion disk, or readily available sustenance, remains effectively invisible through conventional astronomical methods. Its detection was made possible by gravitational microlensing, a phenomenon rooted in Einstein's theory of general relativity. When a celestial body of significant mass traverses the line of sight between Earth and a more distant star, its gravity warps the starlight, inducing a transient period of increased brightness, followed by a gradual dimming as their alignment shifts. Precise measurement of these luminous fluctuations allows astronomers to deduce the mass and trajectory of the intervening object. In this specific instance, the microlensing signature indicated the presence of a dark, compact entity possessing several solar masses, traversing the galactic plane at velocities consistent with a stellar remnant rather than a typical star. This confirmation held considerable importance as it validated theoretical postulations and granted us observational access to a celestial population presumed to be abundant yet seldom observed. Theoretical models suggest that hundreds of millions of stellar mass black holes roam the Milky Way, vestiges of ancient stellar explosions, the vast majority of them remaining entirely unseen and undetected unless they happen to drift directly across the path of a background light source under our observation. Our galaxy is, in essence, populated by unseen gravitational predators, voids in the fabric of space-time poised to engulf anything unfortunate enough to cross their event horizons. Now, considering the context of Atlas, the situation becomes particularly intriguing. Could a rogue black hole have influenced the trajectory of our interstellar visitor? Might gravitational interactions with such an entity account for some of the peculiar orbital characteristics we're observing? Initially, this hypothesis appears plausible. Black holes are immensely powerful gravitational entities. An encounter, even from a considerable distance, would undoubtedly alter an object's path, potentially explaining the trajectory that guided Atlas into our solar system from its unknown stellar origin. However, the mathematical calculations do not entirely align. Gravitational interactions are thoroughly understood, governed by precisely tested equations. For a black hole to significantly alter Atlas's course without either capturing it or accelerating it to far greater speeds would necessitate an encounter of improbable precision, akin to threading a needle in three-dimensional space across vast interstellar distances. While not physically impossible, such an event is exceedingly unlikely. The universe offers numerous other mechanisms for trajectory perturbation that do not involve rogue black holes. Nevertheless, there is a certain metaphorical resonance in the simultaneous emergence of these two anomalies: a homeless black hole and a comet with an indeterminate origin, both adrift in space, both defying our neatly categorized understanding of celestial bodies. Both serve as potent reminders that the galaxy is a far more dynamic, chaotic, and hazard-filled realm than the ordered depictions in textbooks suggest. We tend to envision space as largely empty, punctuated by scattered islands of matter and light. The reality, however, is more unsettling. Space teems with unseen entities, massive objects traversing the darkness, ancient relics of stellar demise drifting between observable stars. The existence of wandering black holes also prompts disquieting questions about other unseen phenomena. If stellar remnants can be forcefully ejected from their birth systems, what about planetary remnants? What about objects that were never gravitationally bound to a system in the first place? And what about entities that were deliberately placed on specific trajectories rather than being subjected to random gravitational forces? Our inventory of interstellar space is largely unknown. We can only observe entities that emit or reflect light towards us. Everything else, in a colloquial sense, remains invisible until it ventures close enough to our instruments to be detected. This observation connects to a broader theme within our investigation. We are discovering that space is not the tranquil, predictable environment we once assumed. The smooth galactic dynamics we envisioned, with everything orbiting gravitational centers in an orderly fashion, are complicated by rogue objects and wanderers, by entities that deviate from the established script. If our understanding of black holes is flawed, if our estimates of their numbers and natures are inaccurate, what else might be incorrect? The timing of these discoveries is also peculiar. Here we are, in the year 2025, tracking an anomalous interstellar object through our solar system, while simultaneously confirming the existence of rogue black holes drifting through our galaxy. While these discoveries are not necessarily interconnected, and astronomy is a rapidly evolving field with constant new findings, the convergence of anomalies and the clustering of strange observations within a brief time frame prompt pattern-seeking minds to question if there's an unseen connection. Correlation does not imply causation, but it can sometimes serve as a clue pointing towards deeper, unrecognized structures. Moreover, black holes are not the sole cosmic anomaly demanding our attention. Concurrent with our observation of objects traversing the galaxy, our own star has developed a significant affliction that impacts all our observational efforts. Let us now direct our focus to the Sun and to a phenomenon that may be obscuring our clear perception of truth. Part 7. The Sun's Colossal Wound. The Sun is not a smooth, uniform entity. We often conceptualize it as a perfect sphere of fusion and light, consistent and predictable, the celestial engine powering our planetary system. However, the reality revealed by solar telescopes is far more tempestuous. The Sun's surface churns with convection cells and tangled magnetic fields. Sunspots emerge and dissipate. Enormous prominences arc thousands of kilometers into space, and at times, the Sun exhibits a wound. Coronal holes, precisely as their name suggests, are gaps in the Sun's outer atmosphere where magnetic field lines do not curve back to the surface, but instead extend outwards into space. These are not physical voids devoid of matter. Rather, they are regions where the plasma is cooler and less dense than the surrounding corona, appearing dark in extreme ultraviolet imagery. Crucially, these are areas from which the solar wind escapes unimpeded, accelerating to speeds of up to 800 kilometers per second, carrying charged particles and magnetic fields deep into the solar system. In October of 2025, solar observatories identified a massive coronal hole directed towards Earth, one of the largest recorded in recent years. This hole spanned a substantial portion of the Sun's visible disk, a dark blemish on its turbulent, luminous surface, akin to a persistent cosmic injury. Forecasters anticipated that powerful streams of solar wind would reach Earth within days, potentially triggering geomagnetic storms, disrupting satellite operations, causing auroras at unusually low latitudes, and generally destabilizing the near-Earth electromagnetic environment. For most individuals, coronal holes are primarily of interest due to their spectacular aurora displays. The charged particles streaming from the sun interact with Earth's magnetic field and atmosphere, exciting atoms and molecules to emit light, painting the night sky with vibrant curtains of green, red, and purple. It is a breathtaking spectacle, one of nature's most impressive light shows, drawing photographers and tourists to high-latitude regions whenever intense solar activity is predicted. However, for astronomers endeavoring to conduct precise observations of faint celestial objects, solar storms present a significant challenge. The deluge of charged particles interferes with radio observations, generating noise that drowns out faint signals. Fluctuations in the magnetic field can affect spacecraft operations, potentially degrading image quality from orbital telescopes. Even ground-based optical telescopes can be impacted as increased ionization in Earth's upper atmosphere distorts the passage of light. When the sun is actively wounded, when coronal holes unleash plasma towards Earth, our capacity to observe the distant universe clearly diminishes. Now, consider the timing. Atlas reached perihelion, its closest approach to the sun, on October 30th, 2025. This was the moment when telescopes should have been gathering the most detailed data, when the object was at its brightest, closest, and most accessible for observation. And precisely at this time, a massive coronal hole was facing Earth, with the solar wind at its peak intensity and the electromagnetic environment most disrupted. Is this a coincidence? Almost certainly. Solar activity follows its own cycles, independent of any asteroids or comets that may happen to be passing through. Coronal holes form according to magnetic dynamics that we do not fully control or predict. The overlap is likely merely unfortunate luck, an ill-timed alignment of observational windows and solar behavior. Or is it? This is where we must exercise caution regarding the narratives we construct. It is exceedingly easy to perceive patterns where none exist, to interpret coincidences as deliberate machinations, to imagine that the universe, or some entity within it, is intentionally orchestrating events to impede our observations. This is almost certainly not the case. However, the effect remains regardless of the cause. During the critical period when Atlas was optimally positioned for detailed study, our instruments were functioning in a degraded environment, struggling through solar interference to acquire data. Any subtle signals, any minute anomalies, any fine details that might have clarified the object's nature would have been more difficult to obtain, easier to miss, and more likely to be obscured by noise. The metaphor is compelling. A hole in the sun, a wound in our star creating a smokescreen during the very window when clarity was most needed. It reads like a thrilling screenplay, designed to maximize uncertainty. And perhaps that is all it is. A coincidence that feels significant because humans are inherently pattern-seeking beings who perceive design even in randomness. Yet, it is also true that if one wished to observe something without being clearly observed, if one desired to pass through a stellar system while remaining enigmatic, timing one's arrival during a period of heightened solar activity would be a strategically advantageous choice. The benefit would be from the degraded observation conditions, the masking of signals by noise, and the reduced clarity of the instruments tracking the object. This presents a dilemma with uncertainty. Once one is immersed in it, Every piece of data can be interpreted in multiple ways. The coronal hole is simply weather, solar dynamics following their own predictable patterns. Alternatively, the coronal hole is a deliberate smokescreen, an interference pattern that benefits an object seeking to maintain ambiguity. Both explanations are consistent with the available facts, yet neither can be definitively proven or disproven with the current information. We are once again left in a state of flux between knowledge and speculation. And the cosmic strangeness does not end with solar phenomena. While we have been observing drifting objects and our star expelling plasma into space, cosmologists have been re-evaluating the ultimate destiny of the universe. Is the universe destined for perpetual expansion, or could it be heading towards a catastrophic collapse? Let us examine how our beliefs about cosmic destiny might be influencing our interpretation of current anomalies. Part 8. The crunch clock begins to tick. The universe is expanding. Every galaxy we can observe is receding from every other galaxy. Space itself is stretching like the surface of an inflating balloon. This has been an empirically confirmed fact since Edwin Hubble's groundbreaking work in the 1920s. Refined through decades of increasingly precise measurements, this expansion is accelerating, propelled by a force we term dark energy, a mysterious cosmic constituent that functions as an anti-gravitational influence on cosmic scales, driving space apart at an ever-increasing rate. According to the prevailing cosmological model, this expansion will continue indefinitely. Galaxies will recede until they vanish beyond our observable horizon. Stars will gradually extinguish. The universe will become cold, dark, and empty, leading to a heat death that unfolds over trillions upon trillions of years. This has been the prevailing consensus, a sort of comfortable nightmare, if you will, a fate so distant and impersonal that it scarcely registers as a threat. We possess time, an inconceivable abundance of it. Whatever may befall humanity, Earth, or our local cosmic neighborhood, the universe itself will endure for eons. Except, in 2025, certain cosmological research papers began to question this fundamental assumption. New analyses of dark energy behavior, subtle patterns detected in the cosmic microwave background radiation, and refined models detailing the evolution of the universe's expansion rate over time all pointed towards a possibility previously dismissed as highly improbable. What if dark energy is not constant? What if it is waning, changing its character, or undergoing a phase transition that would reverse the expansion into a contraction? What if the universe's ultimate destiny is not heat death, but the big crunch, a gravitational implosion that would eventually draw everything back together? Galaxies colliding, space compressing, matter and energy being crushed into a single point, a reversal of the Big Bang. These papers were tentative, heavily qualified, and carefully noted that the evidence was far from conclusive. The odds still favored perpetual expansion. However, the possibility of contraction, once deemed virtually non-existent, was now assigned a small but not negligible probability, perhaps 1% or even 5%. This was sufficient for serious cosmologists to consider it, conduct simulations, and contemplate the observational signatures that would either confirm or refute this hypothesis. Why is this relevant to our investigation of Atlas? Because cosmological narratives profoundly shape how we interpret local events. When the ultimate fate of the universe appears settled, when we are confident in the overarching cosmic story, anomalies are readily incorporated into that stable framework. This comet is peculiar, but the universe is stable, so its peculiarity must be explicable within our existing models. However, when the cosmic narrative itself becomes unstable, when the ending is being rewritten, suddenly everything feels less certain. If we have been mistaken about the universe's ultimate fate, what else might be incorrect? If the fundamental framework is shifting, perhaps these anomalies warrant more attention than we have previously afforded them. There is also a psychological dimension to consider. Narratives of doom, predictions of cosmic endings, tend to intensify during periods of cultural anxiety or significant paradigm shifts. Medieval Europe, for instance, was preoccupied with apocalyptic prophecies during times of plague and social upheaval. The Cold War generated numerous scenarios of nuclear winter and societal collapse. And now, in an era marked by climate disruption, political instability, and rapid technological advancement, we are witnessing a resurgence of interest in cosmic doomsday scenarios, contemplating endings both near and far. The Big Crunch narrative aligns with this pattern. It represents a cosmic reset button, an end that is also a beginning, a collapse that could potentially lead to a new Big Bang and a subsequent universe. It holds a psychological appeal that heat death lacks. Heat death signifies nothing more than the eventual triumph of entropy, a gradual winding down into nothingness. The crunch, however, implies purpose, a cyclical nature, the possibility that universes are born, die, and are reborn in an eternal pattern. It is mythology cloaked in mathematical language, appealing to a deep-seated human desire for existence to possess structure and meaning beyond mere thermodynamics. Therefore, when research papers emerge suggesting that the universe might undergo a crunch rather than expand indefinitely, they are not merely presenting dry technical findings. They are offering a new narrative, an alternative perspective on cosmic destiny. This narrative primes us to interpret present events through a specific lens. If the universe itself is progressing towards collapse, towards a convergence of all that has been diverging, then perhaps interstellar visitors like Atlas are not random wanderers, but integral components of a grander design, a cosmic choreography that currently eludes our understanding. This, of course, ventures into speculative territory. The connection between cosmological models and interstellar objects is tenuous at best, but narratives do not require logical rigor to exert psychological influence. When one believes the universe is on a trajectory towards fundamental transformation, one begins to perceive signs of that transformation everywhere. Every anomaly becomes a harbinger, every mystery a clue. The interpretive framework shifts, and with it, one's understanding of everything within that framework. And here lies an uncomfortable truth. Scientists are human. They are not immune to narrative influence. When the broader culture is fixated on endings and transformations, when cosmological models are in flux, and when established certainties are being questioned, this atmosphere inevitably affects how researchers interpret their data, which hypotheses they deem plausible, and which anomalies they consider worthy of investigation versus dismissal. Science is not an entirely objective process detached from human psychology. It is a human endeavor undertaken by individuals with inherent biases and innate narrative drives. These drives inevitably shape the work. Thus, the Big Crunch papers, regardless of their ultimate validity, alter the interpretive environment. They foster an inclination towards grander thinking, encourage the consideration of cosmic-scale possibilities, and prompt contemplation of whether the anomalies we observe are interconnected with larger patterns. They do not definitively prove anything about Atlas, but they transform the atmosphere within which Atlas is being analyzed. And sometimes, atmosphere plays as significant a role as evidence. However, let us shift our focus from cosmic destiny to more immediate concerns. While astronomers deliberate the universe's ultimate fate, a more prosaic, yet equally disruptive phenomenon has been unfolding in our orbital space. Satellites are falling with regularity, quietly, and their fiery descent may be obscuring something significant. Part 9. Starlink's quiet rain of fire. Every day, somewhere above your head, a satellite ceases to function, not figuratively, but literally. Metal, silicon, and solar panels heat to thousands of degrees as they impact Earth's atmosphere, ablating away, breaking apart, descending as microscopic debris, or occasionally as larger fragments that survive to reach the surface. A Smithsonian astrophysicist recently estimated that 1 to 2 Starlink satellites burn up or fall back to Earth daily, not monthly. That equates to hundreds of objects per year from a single mega constellation vaporizing during their descent. The reason is straightforward physics. Low Earth orbit is not a vacuum. A residual atmosphere persists even at altitudes of several hundred kilometers, sufficient to generate minute amounts of drag on satellites. Over time, this drag decelerates the satellites, lowering their orbits, until eventually they dip into denser atmospheric layers and can no longer maintain altitude. Orbital decay is an inevitable process. Every satellite launched will eventually fall unless continuously propelled to maintain its orbit. For smaller satellites lacking substantial fuel reserves, their operational lifespan might be limited to just a few years before atmospheric drag takes its toll, initiating their final descent. Starlink, SpaceX's mega constellation designed to provide global internet coverage, comprises thousands of satellites in low Earth orbit. The plan envisions tens of thousands eventually, forming a network so dense that from any point on Earth, multiple satellites would be visible above the horizon. This requires operation in low orbits where atmospheric drag is significant, necessitating the regular replacement of satellites as they decay and burn up. Hence, the daily rain of fire, a steady stream of defunct hardware vaporizing overhead, mostly unnoticed because individual events are too small and too common to generate news. However, this phenomenon significantly impacts the observational environment by introducing clutter. Innumerable satellites, reflecting solar rays, obstruct telescope observations. They create luminous streaks across astronomical imagery, necessitating digital removal. This phenomenon heightens the occurrence of false positives, fleeting objects detected in sky surveys that are ultimately identified as satellites or orbital debris rather than asteroids or comets. Consequently, the already formidable challenge of tracking diminutive celestial bodies becomes even more arduous. Observers must meticulously differentiate genuine cosmic occurrences from the escalating accumulation of human-engineered hardware proliferating in Earth's vicinity. For those endeavoring to study phenomena such as Atlas, this distinction is crucial, particularly when analyzing faint objects or discerning subtle shifts in brightness or trajectory. The presence of thousands of artificial entities within a telescope's field of view complicates the endeavor to ascertain the authenticity of an observation or confirm whether it is an artifact. Every enigmatic signal could originate from a satellite, and every unexplained luminescence might be debris catching sunlight at an unusual angle. The ambient noise level escalates, amplifying the difficulty of isolating genuine signals from the pervasive background. Furthermore, a more speculative, yet pertinent, consideration arises. Could the proliferation of satellite activity serve as a deliberate smokescreen for the detection or concealment of other anomalies? If an entity wished to observe Earth discreetly or traverse near-Earth space while maintaining plausible deniability, blending seamlessly with the existing thousands of artificial objects would represent a strategically advantageous maneuver. Any telescope observing such an entity would reasonably assume it to be just another satellite, a piece of orbital detritus, or merely a component of the pervasive clutter that has become commonplace and is routinely filtered out. This camouflage would not be a conscious act of concealment on the part of the observer, but rather a byproduct of humanity's own technological infrastructure, the very constellation of hardware we have deployed around ourselves. This connects to a broader discourse concerning signal versus noise, and how escalating complexity impedes clear perception. The more satellites launched, the more challenging astronomy becomes. As space debris accumulates in orbit, discerning significant observations from the inconsequential grows increasingly difficult. We are actively generating our own atmospheric obscuration, enshrouding ourselves in a technological haze that obscures the very cosmos we aspire to study. Anything seeking to remain concealed, ambiguous, or unobserved inherently benefits from this pervasive haze. The irony is profound. We deploy satellites to enhance communication and observation, providing superior tools for cosmic exploration. Yet, in doing so, we degrade the very environment in which these observations take place, hindering the detection of faint objects, complicating the tracking of anomalies, and making it more difficult to ascertain whether our findings are significant or merely another fragment of falling hardware igniting as it descends. Progress invariably engenders its own impediments. The more sophisticated our technology becomes, the more it tends to interfere with itself. A facile resolution to this predicament remains elusive, as the satellites fulfill purposes valued by humanity, including internet access, weather monitoring, and essential communications infrastructure, all reliant on the orbital constellation. Advocating for a reduction in satellite numbers necessitates relinquishing capabilities and services upon which millions depend. Consequently, the constellation will continue to expand, orbital clutter will intensify, and the observational environment will progressively deteriorate. This is the established trajectory, and without a significant policy overhaul or a groundbreaking technological advancement, it is the course we are destined to follow. This brings us to perhaps the most perplexing facet of the Atlas narrative: the pervasive silence, the discernible lacunae in communication, and the palpable sense that institutions expected to disseminate information are withholding it. Why the reticence from agencies when unusual phenomena emerge? What rationale or apprehension underlies this selective disclosure? Let us scrutinize the silence itself and its potential implications. Part 10. The silence preceding disclosure. Silence itself constitutes a form of information when one anticipates a communication and receives none. When entities that typically maintain regular contact suddenly cease their transmissions, and when the absence of statements becomes more conspicuous than their presence, a signal is being conveyed, albeit a negative one. The silence surrounding Atlas, the temporal gaps between observations and official announcements, and the meticulous scrutiny applied to every public release collectively communicate something, even if its precise meaning remains indeterminate. Space agencies operate under constraints largely unconsidered by the general public. Every image disseminated to the public undergoes rigorous review, calibration, and verification. Every pronouncement concerning observations must be precise, defensible, and unlikely to be contradicted by subsequent data. This is not indicative of censorship or a conspiracy, but rather the inherent caution exercised by institutions whose credibility is contingent upon accuracy. Should NASA announce a discovery that is subsequently revealed to be the result of instrumental error or misinterpretation, the damage to its reputation could be severe and enduring. Consequently, they meticulously review, re-examine, and await confirmation before making any public pronouncements. This process introduces a temporal disparity, a delay between observation and announcement, typically measured in weeks or months. For routine observations, this delay is of negligible consequence. However, consider the implications. If a press release concerning a distant galaxy surfaces 6 months after the telescope captured the initial image, the galaxy in question is not going anywhere. But for time-sensitive events, for celestial objects traversing our solar system on timelines measured in days and weeks, such a delay becomes profoundly significant. By the time an agency is prepared to issue a statement, the event may have long passed, the object moved on, leaving the public to ponder the reasons for the delayed notification. This pattern is observable across numerous recent occurrences. When new exoplanets are identified through gravitational wave detection or transit methods, often months elapse before the discovery is publicly announced. When intriguing signals are detected by radio telescopes, extensive internal verification processes are undertaken before external parties are informed. When orbital missions capture unusual imagery, these images undergo processing and analysis pipelines that can extend for a year or more prior to public dissemination. This constitutes standard operating procedure, not specific to Atlas or any particular mission. However, standard procedure assumes a different tenor when the observation possesses the potential for extraordinary significance. When the delay pertains to data that could elucidate fundamental questions regarding our cosmic provenance, and when the interval between observation and dissemination fosters fertile ground for speculation and alternative narratives, routine caution begins to assume the guise of something more deliberate, a calculated withholding of information, a form of information control, or an institution dictating the parameters of public knowledge and its timing. This is where institutional imperatives generate challenges. Agencies desire control over their narratives. They aim to make announcements according to their own schedules, employing their own terminology and framing. Leaks are detrimental. Premature releases are undesirable. Speculation preceding verification is discouraged. While these considerations are entirely rational from the agency's vantage point, they manifest to the public as an aura of secrecy. Decisions appear to be made behind closed doors regarding the suitability of information for general consumption. This perception, irrespective of its factual basis, erodes public trust. Historical precedents exist for agencies delaying or initially withholding anomalous findings. The iconic Face on Mars, captured by the Viking orbiter in 1976, was initially presented in a press release that emphasized its artificial appearance, before subsequent releases provided context regarding the impact of lighting and resolution on its interpretation. The WOW signal, detected in 1977 by SETI researchers, was not subjected to detailed public discussion for years, despite being one of the most captivating radio observations ever recorded. The dimming of Tabby's star, which some speculated might signify an extraterrestrial megastructure, was known to researchers well in advance of its public disclosure through data release. In each instance, justifiable reasons existed for the delay. Scientists sought to eliminate instrumental error, to accumulate additional data, and to avoid making unsubstantiated claims. However, the cumulative effect was consistent. The public learned of potentially momentous observations long after their occurrence, through channels that resembled public relations management more than transparent scientific communication. Each case reinforced the impression that institutions were acting as gatekeepers of information, dictating which questions were deemed appropriate for public discourse and which were to remain confined to private discussions among accredited experts. Applying this pattern to Atlas, the object was discovered in July. It is now late October. We have witnessed a limited number of images, predominantly depicting faint points of light or streaks. We have perused press releases that emphasize the natural explanation of a comet, downplaying anomalies and assuring us that all is as expected. High-resolution imagery, which instruments should have readily captured, remains unseen. Access to raw spectroscopic data, which would enable independent researchers to validate the chemical assertions, has not been provided. We are implicitly requested to trust that the institutions studying ATLAS are divulging all pertinent information, while simultaneously acknowledging that their historical record suggests otherwise. This creates what might be termed the silence window, the interval between observation and disclosure, during which narrative management occurs. Within this temporal domain, the agency exercises control over the unfolding story. They determine what aspects are highlighted and what is relegated to technical appendices. They frame the discovery in language that shapes public interpretation. This process transpires behind closed doors, within internal meetings and peer review procedures that remain inaccessible to the public. By the time the official account is presented, the narrative has already been meticulously constructed, the interpretation finalized, and the permissible scope of speculation defined. Is this indicative of conspiracy? Not in the sense of a deliberate, malevolent cover-up, but rather as a manifestation of information control, narrative management, and institutional self-preservation. This environment, however, cultivates the fertile ground upon which conspiracy theories flourish. When individuals perceive that they are not privy to the complete account, they tend to fill the void with their own narratives, which are frequently more dramatic and less plausible than the truth would be if it were simply shared openly. ATLAS occupies a central position amidst a confluence of peculiar signals and multiple cosmic anomalies that may or may not be interconnected. These include rogue black holes traversing the galaxy, solar disruptions impacting observations, cosmological models undergoing revision, and satellites descending like a deluge. Each of these could represent isolated, unrelated developments. Alternatively, they could be constituent elements of a grander pattern that eludes our perception due to fragmented data, delayed dissemination, and a narrative fractured by institutional caution and strategic communication practices. What is certain is that an object is currently traversing our cosmic neighborhood, and the models and institutions examining it are exercising discretion regarding the timing and content of their disclosures. The silence could signify nothing, or it could portend everything. We shall not know until the window of silence closes, until the data is finally released, allowing us to ascertain the true nature of ATLAS for ourselves. Until then, we are left with conjecture and educated guesses, gazing skyward and pondering what is being observed but deliberately withheld. Shifting our attention to the celestial calendar, while these strange occurrences unfold, cosmic events continue their inexorable march, governed by the principles of orbital mechanics and astronomical timing. These events, these spectacles, may serve as distractions or as opportunities. They might obscure that which we need to perceive or illuminate that which has been concealed. Regardless of their role, they are imminent. Mark your calendars. The spectacle is about to commence. Part 11. The cold moon ascends. December 4th. The moon possesses a multitude of appellations, inherited from cultures that meticulously tracked its phases as both calendar and clock. The full cold moon is slated to ascend on December 4th, 2025. This designation, bestowed by colonial Americans following indigenous traditions, links this particular full moon to the advent of deep winter, characterized by frigid nights and frozen earth. As the year draws toward its darkest point, before the solstice heralds the eventual return of light. There is an inherent primal resonance associated with full moons, having influenced human behavior for millennia, marking periods for hunting, cultivation, ritual, and celebration. Modern individuals often assume a detachment from such influences, believing that electric illumination and digital calendars have liberated us from lunar dominion. Nevertheless, hospital emergency rooms continue to report heightened activity during full moons. Police departments note alterations in call patterns, and sleep studies reveal measurable impacts on human circadian rhythms, even when subjects are shielded from direct lunar observation. We remain animals, still subject to the ancient rhythms under which our ancestors evolved. Even if we consciously disavow this connection, the cold moon will be globally visible, weather permitting. It will rise in the east concurrently with the sunset in the west, reaching its zenith around midnight, suffusing the landscape with a peculiar, colorless brilliance. This illumination is sufficient for reading, but insufficient for discerning color. It represents a liminal light, suspended between day and night, rendering the familiar world uncanny and the uncanny world discernible. From a purely astronomical standpoint, this full moon is unremarkable. It is not a supermoon, nor is it unusually proximate, expansive, or luminous. It is simply the moon completing another orbital cycle, reflecting sunlight back towards Earth. However, from symbolic, cultural, and psychological perspectives, it holds significance. Individuals will venture outdoors to observe it. Photographers will capture its ascent over diverse landscapes and urban vistas, and social media will be inundated with images of the moon, each a unique attempt to encapsulate the ineffable sensation of standing beneath its glow, feeling simultaneously diminished, interconnected, and ancient. Now, consider a speculative overlay. Might phenomena such as Atlas be deliberately or coincidentally timed to coincide with periods of intense public attention directed elsewhere? The full moon serves as a natural spotlight, a celestial event that draws countless eyes upward. When people are captivated by the moon, their attention is diverted from other celestial objects. When telescopes are directed towards the moon or contend with its luminosity, thereby obscuring fainter objects, they are not tracking anomalies in other sectors of the sky. In essence, the moon creates a blind spot, a moment of collective focus that can mask concurrent events. This is not to posit a cosmic conspiracy involving extraterrestrial visitors coordinating their arrivals with lunar phases. Such a notion is patently absurd. Rather, it is to acknowledge that periods of concentrated human attention in one direction invariably create opportunities in others. Magicians adeptly employ this principle. Misdirection lies at the heart of their craft. By directing the audience's gaze to their right hand, they divert attention from their left. Similarly, by focusing public attention on the moon, other celestial movements occurring in the darker expanse beyond may go unnoticed. The cold moon also carries symbolic weight, influencing our interpretation of events transpiring around its temporal proximity. Cold suggests finality, dormancy, and the conclusion of a cycle. December is a period of natural decline, cessation of growth, and an inward turning of the world. Should anomalous events cluster around this timing, or should disclosures or discoveries occur in early December, they would inevitably be filtered through this symbolic lens, interpreted as endings rather than beginnings, as closure rather than initiation. The narrative framework shifts based on the timing of revelations, even if such timing is purely coincidental. And perhaps it is purely coincidental. Perhaps lunar phases and extraterrestrial visitors are entirely unrelated. Perhaps the cold moon is merely the moon, and Atlas is simply passing through, and any perceived connection between them is a result of pattern recognition applied to random occurrences. However, humans are intrinsically storytellers. We are compelled to perceive narratives within events, connections within coincidences, and meaning within temporal alignments. The moon ascends, the visitor traverses, and within the overlap, we construct a narrative that resonates with our understanding, even if it deviates from the universe's inherent logic. The paramount imperative is to acknowledge one's own perceptions. When the cold moon rises and your gaze is drawn heavenward, inquire about other concurrent occurrences, other objects traversing space, what data is being released or withheld, and what announcements are being made or deferred. The moon is a magnificent spectacle, worthy of observation, photographic capture, and celebration. However, its beauty should not serve to obscure the entirety of the celestial expanse. Occasionally, a spectacle is merely a spectacle. At other times, it functions as a veil for something that would otherwise command our attention. Speaking of spectacle, the cold moon represents merely the opening act. A supermoon is on the horizon, larger and brighter, poised to dominate headlines and social media feeds. Let us examine how the most significant lunar display of 2025 might be shaping our perceptions and obscuring other phenomena. Part 12. The Supermoon of 2025. Early November. The term supermoon evokes a sense of drama, reminiscent of comic books or disaster films. While the reality is more nuanced, it remains genuinely awe-inspiring. A supermoon occurs when the full moon coincides with perigee, the point in the moon's elliptical orbit where it achieves its closest approach to Earth. The moon's orbit is not perfectly circular, but elliptical, meaning its distance from Earth fluctuates by approximately 50,000 kilometers. When a full moon aligns with perigee, it appears roughly 14% larger and 30% brighter compared to when it is at apogee, its farthest orbital point. This difference is visually perceptible, particularly when the supermoon rises near the horizon, where atmospheric refraction can enhance its apparent size through an optical illusion. The most prominent supermoon of 2025 is anticipated in early November, likely on either the 3rd or 4th, contingent upon the precise measurement of perigee relative to the moment of full illumination. For casual observers, this distinction holds little import. What is significant is that for several consecutive nights, the moon will command the nocturnal sky, its luminosity casting pronounced shadows, its beauty captivating observers, and its attention-grabbing nature transforming it into a cultural phenomenon rather than a mere astronomical event. And therein lies the crux of our interest. Supermoons generate immense public engagement. They represent an accessible form of astronomy, requiring no specialized equipment beyond one's own eyes and innate curiosity. News outlets provide extensive coverage, weather forecasts mention them, and social media platforms teem with supermoon photographs captured from every conceivable vantage point and angle. For a period of several nights, millions of individuals, typically disinclined to contemplate celestial mechanics, transform into amateur lunar observers, stepping outside to gaze upward, sharing their experiences, and participating in a collective astronomical event. This is, in itself, a positive development. Anything that fosters public interest in space encourages contemplation of the cosmos and connects individuals to the universe beyond their immediate concerns represents a net benefit for human civilization. However, it also constitutes a substantial redirection of attention. When the collective focus is fixed upon the moon, when telescopes are occupied with its brilliance, and when the broader cultural discourse is dominated by imagery of the supermoon, other phenomena can transpire with significantly reduced notice. Atlas's closest approach to Earth occurs in late October, immediately preceding the November supermoon. This temporal alignment signifies that as Atlas navigates the most observable phase of its trajectory, public attention is poised to be captivated by a lunar spectacle. Professional astronomers, of course, will continue to track Atlas. Their observations are not swayed by aesthetically pleasing moons. However, public attention, media coverage, and the prevailing conversation regarding events in space will inevitably pivot towards the more accessible and visually striking celestial display. Atlas will recede into the background, if mentioned at all, overshadowed by the supermoon's mainstream appeal. A historical pattern merits noting in this context. Major announcements are often deliberately released when the public's focus is diverted elsewhere. Governments are known to introduce unpopular legislation on Friday afternoons, just before long holiday weekends. Corporations frequently disclose unfavorable financial reports after the stock market has closed for the day. This isn't necessarily indicative of a conspiracy. Rather, it's a strategic approach to communication, where the timing is chosen to minimize negative public reaction or to allow the information to be absorbed without immediate, intense scrutiny. Could this same tactic be employed when dealing with celestial anomalies? Is it possible that the timing of disclosures, or the withholding of information, is intentionally synchronized with significant astronomical occurrences as a strategy to manage public response? Perhaps. Alternatively, the timing could be entirely happenstance, a consequence of orbital mechanics and the availability of observational opportunities that have no connection to communication strategy. Regardless of the intention, the effect is undeniable. When a supermoon commands the public's attention and shapes the discourse surrounding space, anomalies like Atlas tend to recede into the background. Questions that might otherwise be loudly voiced in a less crowded news cycle are either asked in hushed tones or go unasked entirely, drowned out by the excitement surrounding the supermoon. Adding to this is a psychological dimension. Supermoons, in a peculiar way, offer a sense of comfort. They are predictable, anticipated, and a consistent part of the universe's regular celestial rhythm. They serve as a reminder that certain aspects of the cosmos remain stable, that orbital patterns adhere to understandable laws, and that we can accurately forecast and prepare for these events. In an era marked by cosmic uncertainty, where discussions of extraterrestrial visitors, rogue black holes, and apocalyptic cosmological scenarios are circulating within scientific circles, the supermoon provides a measure of reassurance. It conveys a message. The universe still operates according to the principles you learned in school. The moon continues its orbit around Earth. Perigee and apogee still occur on schedule. Not everything is inherently strange. This sense of reassurance, this return to the familiar, might be precisely what people psychologically require. Conversely, it could also be the very thing that prevents them from confronting genuinely perplexing developments. When comfort is readily available and a spectacular event offers a convenient focal point, it becomes tempting to embrace that distraction and disregard the more challenging, unsettling questions lurking just beyond the spotlight's illumination. While the supermoon is undeniably beautiful, its beauty can be a form of entrapment, drawing your gaze in one direction while leaving other avenues unexplored. Therefore, when the supermoon graces the sky in November, with its magnified and intensified disk dominating the celestial sphere, make a conscious effort to look beyond it. Observe what else is visible. Inquire about the data being disseminated or withheld. Note whether announcements are coinciding with the supermoon's presence or are strategically postponed until after the spectacle has concluded. The moon certainly warrants attention, but it should not monopolize it. The sky encompasses far more than its brightest occupant, and sometimes the most significant events unfold in the darker, less examined regions. Speaking of phenomena streaking through the darkness, the supermoon is not the sole celestial display anticipated in the coming months. Meteor showers are on the horizon. These are annual occurrences that adorn the night sky with streaks of light, possessing their own capacity to capture attention and, potentially, to obscure phenomena that warrant our notice. Let us now turn our attention to the southern Taurids and the implications of a sky filled with trails of light. Part 13. Fiery spectacle in the sky, the southern Taurids. Each year, during the early days of November, Earth's journey through space brings us into contact with a stream of cosmic debris originating from Comet Enki. This short-period comet traverses the inner solar system approximately every 3.3 years. The remnants form a veritable river of particles scattered along the comet's orbital trajectory. As Earth intersects this stream, these particles collide with our atmosphere at speeds approaching 30 kilometers per second. The resulting friction ignites them, causing them to vaporize in brilliant flashes. We refer to this as a meteor shower, specifically the southern Taurids, so named because the meteors appear to emanate from the constellation Taurus. The southern Taurids are not typically the most dramatic meteor shower. Their peak activity usually produces a modest rate of only 5 to 10 meteors per hour, a considerably lower count compared to showers like the Perseids or Geminids, which can deliver dozens or even hundreds of meteors per hour during their most active phases. However, the Taurids are known among meteor enthusiasts for their propensity to produce fireballs, meteors of exceptional brightness that can momentarily outshine even the most brilliant stars. Occasionally, these fireballs leave behind persistent trails of luminous ionized gas that linger in the sky for several seconds after the meteor itself has disappeared. The shower remains active from late September through late November, with its peak activity typically occurring in early November, coinciding with the supermoon window we previously discussed. Consequently, during the same period when the moon is unusually luminous and public focus is directed skyward, the heavens are also intermittently illuminated by meteors, natural fireworks that contribute to the spectacle and reinforce the impression of a multitude of events unfolding above us. From one viewpoint, this temporal overlap is entirely coincidental. Earth's orbit is fixed. The debris stream from Comet Enki occupies its designated path, and the moon's perigee occurs according to its own schedule. These are independent phenomena governed by gravitational forces that are indifferent to human observation or interpretation. The simultaneous occurrence of these events is simply a reflection of the universe's dynamic nature, with multiple activities unfolding concurrently. From another perspective, this overlap creates a form of observational noise. When one is attempting to track specific celestial objects, searching for anomalies or unusual trajectories, a sky filled with meteors complicates the task considerably. Each streak of light necessitates identification. Is it a Taurid meteor? Is it a satellite? Is it space debris? Or is it something else entirely? The greater the number of natural phenomena occurring, the more challenging it becomes to discern the signal from the noise, the genuine anomaly from the expected event. Herein lies a speculative question that warrants consideration. Could fragments originating from interstellar objects be misidentified as meteors? As Atlas proceeds through the solar system, it is outgassing, shedding material that forms a tail, a cloud of particles following its orbital path. If Earth were to pass through this stream of particles, and if pieces of interstellar matter were to enter our atmosphere, would we recognize them as distinct from the annual meteor showers we anticipate? Or would we simply assume they were part of the Taurids, mere additional debris from Comet Encke, and forego further investigation? Spectroscopic analysis of meteors should reveal compositional differences. The chemical signatures of material originating from an interstellar object should differ from those of comets within our solar system. However, this assumes that a spectrum of the specific meteor in question is captured, that the observation occurs during the fleeting seconds the meteor is visible, and that an observer notices something sufficiently unusual to warrant detailed examination. For the overwhelming majority of meteors, we witness a streak, perhaps capture a photograph, and then move on. In-depth spectroscopic analysis is typically reserved for the most compelling or well-documented cases. This creates an effect of pattern blending. High meteor activity provides a form of camouflage, a backdrop of anticipated events that can obscure unexpected ones. If one intended to study Earth without being readily detected, perhaps by shedding material that might enter Earth's atmosphere, timing that process to coincide with a major meteor shower would be a strategically advantageous move. The ejected debris would blend with expected debris, and the signals would be lost within the background of expected phenomena. Human observers, seeing what they anticipate, would classify everything as part of a known event without closer inspection. Again, this is purely speculative. There is no current evidence to suggest that fragments from Atlas are entering Earth's atmosphere, nor is there proof that anything unusual is concealed within the Taurid stream. However, the structural possibility exists, a theoretical window where misidentification could occur. And this possibility is worth acknowledging, as it impacts the confidence with which we can assert our understanding of what we are observing. Furthermore, there is the straightforward reality that meteor showers inherently draw attention upward. Similar to a supermoon or any other celestial spectacle, they concentrate observers' focus in specific directions at particular times. When individuals are outdoors observing Taurid fireballs, they are engaging with the sky in ways they might not ordinarily. They are actively noticing, pointing out, and photographing celestial phenomena, but their attention is primarily directed towards the meteors, the anticipated performance. Other objects traversing the sky might be visible, but would likely be perceived as background elements to the main event. The Taurids also carry a certain mystique within astronomical communities. Some researchers have posited that the Taurid complex, the extensive debris stream associated with Comet Encke, might contain larger fragments, rocky bodies of significant size that could pose potential impact risks to Earth. These assertions are controversial and not universally accepted, yet they introduce an undercurrent of potential danger to what is otherwise a visually appealing annual event. While watching Taurid meteors, one is observing small particles posing no threat. However, the question might linger in the back of one's mind. Could something larger be concealed within the same debris stream, possibly on a collision course? Atlas, it must be noted, is not part of the Taurid complex. Its origin is interstellar, entirely unconnected to Comet Encke. Nevertheless, the psychological association, the linking of celestial phenomena with potential peril, creates a framework where anomalous objects can be interpreted through a lens of danger. The Taurids serve as a reminder that space harbors hazards. Atlas, arriving from interstellar space with unusual characteristics, might be categorized within this hazard framework, even though it poses no direct collision risk. The narratives intertwine, not due to factual connection, but because they tap into similar psychological responses. Therefore, when the southern Taurids reach their peak in early November, and the sky becomes alive with streaks and fireballs, direct your attention not solely to the meteors themselves, but also to what else might be in motion. Observe whether any unusual objects are reported and subsequently dismissed. Consider whether the blending of patterns is innocent or conveniently masks something else. The Taurids are indeed worthy of observation. They represent a genuine natural wonder and a testament to our existence within a dynamic system where matter is in perpetual motion. However, do not allow the anticipated spectacle to blind you to potentially unexpected performances occurring elsewhere in the sky. And the Taurids are merely the prelude. Additional meteor showers are on the way, a cascade of celestial fireworks scheduled to illuminate the heavens throughout November and into December. Let us examine how this clustering of notable events might influence our perception of what is visible and what remains concealed in the spaces between these fleeting trails of light. Part 14. The Leonids, Geminids, and Ursids, a cascade of showers. The celestial sphere during the latter part of 2025 is remarkably active, not only with the presence of Atlas and the supermoon, but also with a consistent schedule of meteor showers. 3 prominent displays are set to occur in rapid succession, resembling a meticulously coordinated performance orchestrated by the cosmos itself. The Leonids arrive on November 17th and 18th, originating from the debris of Comet Tempel-Tuttle, producing meteors that appear to radiate from the constellation Leo. The Leonids are renowned for their occasional ability to produce meteor storms, events characterized by thousands of meteors per hour gracing the sky, although these storms occur only in specific years when Earth traverses particularly dense regions of the debris stream. The year 2025 is not predicted to be a storm year. The Leonids are expected to be modest, perhaps producing 10 to 15 meteors per hour at their peak, most visible in the pre-dawn hours when Leo is at its highest point in the sky. Following the Leonids, we have the Geminids on December 13th and 14th. These are widely regarded as the most dependable and impressive meteor shower of the year. The Geminids possess a unique origin, stemming not from a comet, but from an asteroid known as 3200 Phaethon. This rocky body may be an extinct comet that has shed all its volatile materials, leaving behind only its solid core. The Geminids can yield up to 120 meteors per hour during their peak activity. These are bright, multicolored streaks observable from virtually any location on Earth, weather permitting. They represent a reliably spectacular display, the kind of event that garners media attention and encourages people to brave the December chill to witness. Finally, the Ursids conclude the year's major showers on December 21st and 22nd, appearing to originate from the constellation Ursa Minor and are composed of debris from Comet Tuttle. The Ursids are typically less prolific, producing perhaps 5 to 10 meteors per hour. They also suffer from an unfortunate temporal placement, peaking around the winter solstice, when nights are longest in the northern hemisphere, but weather conditions are often unfavorable. They serve as a less spectacular, though still regular, closing act to the year's meteor calendar. 3 significant showers occurring over a 5-week period, overlapping with Atlas's passage through the inner solar system, the supermoon, and increased solar activity from that coronal hole. If one were to design a period of maximum celestial activity, a time of heightened sky phenomena, and increased opportunities for both human observers and instruments to be directed upwards, it would be difficult to schedule it more effectively than this. The universe has presented a remarkable autumn and early winter, a season brimming with cosmic displays that will undoubtedly engage astronomers and casual observers alike for months to come. This is where the clustering of events raises pertinent questions. When meteor showers are concentrated and the sky is regularly streaked with anticipated phenomena, the observational environment becomes inherently more complex. Every object of unknown origin must be differentiated from the established background. Every anomalous observation must compete for attention against spectacular yet explainable events. The meteors themselves are beautiful and scientifically interesting in their own right, worthy of observation. However, from the perspective of tracking other celestial objects, they function as noise, creating a baseline of activity that other signals must surpass to be noticed. Could fragments originating from interstellar objects, or dust clouds trailing Atlas's trajectory, or particles shed during its passage through our solar system, coincide with these regular meteor showers? Could material originating from another star system be entering Earth's atmosphere at this very moment, burning up alongside Leonid or Geminid meteors, and subsequently being misclassified or simply overlooked because we expect to see meteors during these periods, and we perceive what we anticipate? The underlying chemistry would reveal the truth if sufficient scrutiny were applied. However, we are not capturing detailed spectra of every single meteor. We are not analyzing every visible streak. The vast majority of meteors are observed visually, perhaps photographed, and that is the extent of the observation. Only a small fraction receive the detailed scientific attention that would uncover unusual composition. Therefore, if interstellar material is intermingled with solar system material, if anomalous particles are hidden among expected ones, the probability of detection is low unless something is overtly different, spectacularly strange, and impossible to misclassify. There is also a human factor to consider. When celestial events are integrated into the annual calendar, when they are anticipated, expected, and normalized, they become part of our perceived background reality. The Geminids occur every December. The Leonids appear every November. These are accepted facts, regular occurrences as predictable as the changing seasons. They are not mysteries. They are anomalies. They represent cosmic infrastructure, the predictable rhythm of Earth's orbit carrying us through debris streams left by various comets and asteroids. This normalization is beneficial. It allows us to forecast and prepare for these events, to schedule observations and public engagement activities, transforming potentially chaotic cosmic phenomena into comprehensible patterns. However, it also creates blind spots. When something becomes normalized, we cease to question it. We no longer view it with fresh eyes. We classify it, file it away, and move on. And if something genuinely unusual is concealed within this normalized pattern, we may entirely miss it because we have trained ourselves not to examine too closely events that we believe we already understand. The clustering of these showers around Atlas's passage could be purely coincidental. Orbital mechanics are oblivious to human narratives. Earth's trajectory through various debris streams is dictated by gravitational laws that operate independently of any interstellar objects happening to be passing through simultaneously. There is no inherent reason to believe the timing is coordinated or imbued with special meaning, except that timing, by its very nature, creates context. When significant news stories emerge during periods of public distraction, they receive less attention. When important developments occur while the public's attention is diverted elsewhere, they can be overlooked or understated. The same principle may apply on a cosmic scale. When the sky is filled with anticipated spectacles and meteor showers, supermoons, and other regular phenomena dominate public attention, anomalies may pass with less scrutiny than they would have garnered during quieter periods. This is not necessarily intentional. It does not require conspiracy or deliberate coordination. It is simply the natural outcome of attention being a finite resource. There are only so many hours in the night, a limited number of telescopes available for sky observation, and a finite capacity for data analysis. When a great deal is happening, not everything receives equal attention. Priorities are established, resources are allocated, and some events, potentially significant ones, may be relegated to lower priority simply because they are competing with more immediate or more spectacular phenomena. Therefore, as the Leonids streak across the sky, the Geminids blaze, and the Ursids mark the year's end, remember that you are witnessing a curated spectacle. This curation is not orchestrated by any human hand, but is rather a product of the inherent limitations of attention and observation. What you see is what is brightest, most obvious, and most expected. What you do not see may be more important, hidden within the darker spaces between the meteors, moving through the sky, while your gaze is fixed on the streaks of light. This brings us to the overarching question that has been subtly present throughout this investigation. Are all these cosmic events, the moons, the meteors, the coronal holes, and the anomalies, merely products of timing, mere coincidences, or simply the universe being simultaneously active in multiple unrelated ways? Or is there a larger pattern at play, a pattern we are failing to recognize because we are too immersed to perceive it clearly? Let us step back and examine the calendar itself and consider whether we are perhaps living through a countdown to an as-yet unidentified event. Part 15. Calendar or Countdown. Consider the collection of phenomena we have assembled. An interstellar object exhibiting anomalous characteristics traversing our solar system. A rogue black hole wandering through our galaxy. A significant coronal hole disrupting solar observations. Scientific papers suggesting the universe might eventually contract rather than continue expanding indefinitely. Satellites experiencing daily failures, contributing to observational noise. A supermoon capturing public attention. 3 major meteor showers clustered within a 5-week span. The rising of the cold moon, imbued with symbolic weight of finality and closure. Individually, each of these events is explicable, natural, or at the very least, not entirely unexpected. The universe is vast and dynamic, and strange occurrences are a regular occurrence. The probability of encountering multiple peculiar events simultaneously should not be surprising, given the immense sample space and the vast number of potentially interesting cosmic phenomena. Some degree of overlap is, therefore, inevitable. However, there is something about the convergence of these events that tends to trouble minds predisposed to pattern recognition. These are not merely random occurrences scattered haphazardly across time. They are concentrated, clustered within a narrow window extending from late October through December of 2025. Furthermore, in various ways, they all impact either our capacity for clear observation or our attention as observers. The coronal hole degrades instrumental performance. The supermoon commands public attention. The meteor showers generate background interference. The failing satellites introduce clutter. Atlas navigates through this all, remaining ambiguous and anomalous, observed but not clearly understood, questioned but not definitively answered. Therefore, we are presented with 3 potential interpretive frameworks, 3 distinct ways of understanding the phenomena we are witnessing. The first is that of pure coincidence. The universe operates independently of human observation or interpretation. These events are separate phenomena that happen to coincide due to the nature of random distributions, which occasionally produce clusters. Coincidences do occur. The perception of patterns is merely a human inclination to find significance in random occurrences. This is the most sensible perspective, requiring no extraordinary claims or convoluted theories. It is likely the correct one. The second interpretation involves circumstantial concealment. It's not about secret plots or concerted efforts, but rather a structural circumstance where genuine anomalies are amplified by coinciding with periods of intense activity and distraction. If Atlas represents something unusual, something that would draw considerable attention in less busy times, its passage during a season of major events offers inherent obfuscation. This isn't due to any planned strategy, but because the crowded observational environment makes focusing difficult, confirmation elusive, and dismissal or postponement for later analysis easier. Within this framework, the timing doesn't need to be intentional to have consequences. The effect exists independently of motive. The third viewpoint, cosmic choreography, is the most speculative and challenging to substantiate, yet it warrants discussion. What if these occurrences are interconnected on a level beyond our current comprehension? What if Atlas is part of a larger phenomenon or process that simultaneously impacts multiple aspects of our cosmic surroundings? We have been operating under the assumption that these are isolated elements, separate incidents happening concurrently. However, what if they are somehow linked? What if rogue black holes, interstellar travelers, solar fluctuations, and even the distribution of meteor showers are connected through mechanisms we have yet to discover? From this perspective, we are not observing mere coincidences. We are witnessing a sequence whose underlying logic remains obscure because we lack the necessary theoretical foundation to grasp it. Each of these frameworks possesses its own advantages and disadvantages. The coincidence perspective is economical, but may potentially overlook genuine unusual events. The circumstantial concealment viewpoint acknowledges structural influences without necessitating intent, though it might overemphasize random noise. The cosmic choreography framework is intellectually stimulating, but demands evidence that is currently unavailable and likely to remain so. The decision of which to favor involves not only analyzing the data, but also considering fundamental beliefs about the nature of the universe, whether it harbors concealed designs, and if coincidence is invariably just coincidence. What is evident is that the celestial schedule for the latter part of the year 2025 has presented an exceptionally abundant array of phenomena. Whether this abundance is accidental or deliberate, whether its timing facilitates or hinders our understanding, whether we are experiencing typical cosmic activity or something more profound, these questions cannot be definitively answered with the present information. We are left in a state of uncertainty, observing the heavens, monitoring the timeline, and pondering whether the calendar marks the passage of time or an impending event. And here lies a final, disquieting thought. Perhaps the inquiry itself is the core issue. Perhaps what truly matters is not whether Atlas is a natural or artificial object, whether its timing is by chance or design, or whether we are witnessing something extraordinary or simply misinterpreting the mundane through the filter of our hopes and anxieties. Perhaps what matters is that we are posing these questions at all, that we are looking skyward, that we are confronting ambiguity rather than seeking absolute certainty. The narrative surrounding Atlas, the story we are crafting about its nature and significance, reveals as much about us as it does about the object itself. It demonstrates our capacity to navigate uncertainty, whether we leap to conclusions or tolerate not knowing, whether we place trust in established authorities or challenge them, and whether we require the universe to conform to predictable patterns for our psychological comfort. Therefore, gaze upwards. Observe the serene ascent of the moon. Count the meteors as they blaze across the night. Note the brilliance of the supermoon and the darkness that frames it. Track Atlas as it traverses our solar system and vanishes back into the interstellar expanse. But also look within. Acknowledge what you wish to believe and the reasons why. Recognize what makes you uneasy and what that unease serves to protect you from experiencing. Identify the narratives you construct about the events in the sky and understand them as stories, human creations superimposed upon phenomena that exist independently of our interpretations. The calendar marches onward. The countdown, if there is indeed a countdown, proceeds according to sequences beyond our control. Events will transpire. Data will eventually be disclosed or remain concealed. Questions will be answered or will evolve into new inquiries. And we will be here, observing, contemplating, constructing narratives, for that is the human response to mystery. Who orchestrated this sequence? The convergence of celestial events across these particular months? Was it orchestrated at all? Or is that very question a misunderstanding, an attempt to attribute agency to processes that simply exist? The universe does not compose. It does not plan. It unfolds according to principles we partially grasp, generating arrangements that occasionally appear intentional, but might merely be the unavoidable outcome of complexity evolving over immense periods. Alternatively, it is conceivable that some arrangements are indeed designed. Some timing is purposeful. Some entities passing through our sky carry intent rather than mere inertia. We are uncertain. We cannot be certain. Not yet. Not with our current observational and measurement capabilities. However, we can remain receptive to this possibility while avoiding the pitfall of absolute conviction in either direction. If you subscribe to the notion that Atlas is merely a comet, you may be correct. You may also be missing the most significant discovery in human history because you prioritized comfort over unease, certainty over doubt, the familiar over the truly unknown. If you believe the narrative that Atlas is something more, you might also be right. You might also be engaging in pattern recognition of random data, perceiving design in randomness, and fabricating elaborate explanations for information that admits simpler interpretations. The only intellectually honest stance is one of skepticism coupled with attentiveness. Skepticism stemming from the recognition that we lack sufficient knowledge to draw definitive conclusions. Attentiveness to what the universe is revealing to us, even when it is unsettling or ambiguous. The cosmos is unconcerned with our beliefs about it. It simply exists. And we, transient observers with limited tools and inherently biased interpretations, endeavor to decipher its messages encoded in light, gravity, and the movement of celestial bodies across immeasurable distances. Look up, but also question whether anyone composed the schedule. Ask what you are overlooking while focusing on the most conspicuous. Inquire whether the narrative you have accepted is one you have chosen or one you have been presented with. The cosmos is vast, enigmatic, and indifferent to human storytelling. Yet, we are creatures who construct narratives, and the stories we tell about what lies above us shape our understanding of ourselves. Therefore, craft these stories with care. Scrutinize them rigorously, and remember that the most accurate response to cosmic enigmas may always be, at least for now, this: we do not know, but we are observing. And that act of observation itself is the genesis of wisdom.